Now let's look at the recipe for designing a dynamic programming algorithm. The first step is to define the subproblem in words. To see what I mean by this, let's look back at the simple example of Fibonacci numbers. In that example, our subproblem definition was f of I is the ith Fibonacci number. The second step in our recipe is to state a recursive relation. We want to express the solution to the ith subproblem in terms of smaller subproblems. So for the instance of Fibonacci numbers, we want to express f of I in terms of f1 through fi minus 1. Because if you recall our dynamic programming algorithm for computing the Fibonacci numbers, we computed f1 up through fi minus 1. So those will be stored in our table, and then we can use those to compute f of I. Now for the case of the Fibonacci numbers, it was straightforward to express f of I in terms of smaller subproblems. Namely, f of I is the sum of the previous two Fibonacci numbers. Now let's figure out how to follow this recipe for the longest increasing subsequence problem. Now let's follow the first step in our recipe. We want to define the subproblem in words. Our first attempt is always going to be to use the identical problem on a prefix of the input. In this case, that means we're going to look at the longest increasing subsequence on the first I elements of the input array. Therefore, we're going to make a new function, L, which is the length of the longest increasing subsequence on the first I elements of the input. Now we want to figure out how to express L of I in terms of L1 through Li minus 1, smaller subproblems. To do this, let's take a look back at our earlier example and see if we can gain some intuition.